Jai Hind everyone, this is Jyoti Sharma, once again giving you a lecture on switchgear components, which is one of the topic in Unit 5 from the course Fundamentals of Electrical Engineering, having the subject code of BEE 101 according to AKTU. Coming to switchgear, what do we understand with switchgear? So if at all I see, it is an apparatus used for switching, controlling and for protecting the electrical circuits. It includes a wide range of switching devices. It also includes the combination of these devices with associated control, measuring, protecting and regulating equipments. Right? They can be connected with the generation systems or the transmission system or the distribution system or the conversion system as well. Low tension switchgear, right? Here we are discussing with the low tension switchgear components. So what is a low tension? So these are generally rated up to 1000 volts or 1500 volts DC, right? So the commonly used low voltage devices for the switchgear protections, right? That includes oil circuit breakers or air circuit breakers, switch fuse units, offload isolators, ELCB, earth leakage circuit breakers, RCCB, that is residual current protective devices, MCB, miniature circuit breakers and MCCB, that is molded case circuit breakers. We will be seeing these individually, right. All these accessories, these are required to protect the low tension system. The most common use of this is in the low tension distribution board. The very basic component or the very first component which can be seen is the switch fuse unit, right? If at all we see here, so this is a dual pole ironclad switch, right? This is generally used for the DC construction, for the DC components, right? Either the DC transmission or generation or distribution, right? That is dual pole ironclad switch. This is triple pole ironclad switch, right? Where we used to have 3 wire system. If at all we want to have the neutral, here also we can be having TP, triple pole, neutral being taken and then the ironclad switch, right. This construction definitely depends upon, the main components what we are having here is the frame of the switch fuse unit, then the fuses. We obviously has seen the fuses in our homes, right. Earlier it used to be only the fuse unit, now it is the switch fuse unit which are generally being used, right. Now, in these fuse, we know how they operate. We used to have a thin copper wire which used to be connecting the line in the neutral terminal, right. With the overcurrents, with the faulty currents flowing or the overcurrent flowing, these copper wires which are very thin, they are having very less resistance. So, because of that, they used to break off, right. If they are being braked off, then the circuit is also being braked off. Right, they used to act like a circuit breaker. Now, this is a complete switch fuse unit. So, we are having fuses, the 2 fuses. With that, we are having the disconnecting link. And these are operated with the operating handles. Right. This is the final cover. Used to have the rubber rings. The rubber rings protect these terminals to be coming in directly contact with the frame body. Right. Now, the next important component, that is MCB, that is miniature circuit breaker. What are the differences between, if at all I say, a miniature circuit breaker, which makes it more superior compared to a switch fuse unit? Then, compared to a switch fuse unit, if at all I see, it is more sensitive towards the current, right, and also towards the over voltage, right. It provides the protection against the overcurrents as well as the short circuit faults. Thermal operation, which is nothing but the overload protection, that is also achieved with the help of bimetallic strip. We will be seeing how this is getting into the operation. If at all I see here, this is the complete structure for the cross section of a miniature circuit breaker, right. Now, the main function is being done with this bimetallic strip. In case, what is happening? In case of overload, right, this bimetallic strip, right, that used to get deformed, right. as this is being deformed, this is being connected to the latch point, right? So the latch point is displaced. When the bimetallic strip is deformed, the latch point is being displaced, right? Which makes this moving contact to be away from the fixed contact. From this fixed contact, the moving contact used to get away, making the circuit breaker to be in off position, to be in open condition. In case of overcurrents, right, in case of faults, if at all there is some fault occurring, in that case, this trip coil, right, there used to be an MMF induced in this trip coil. Because of that, once again, this MMF will drive the plunger, which will once again be resulting in the displacement of this latch point, right. Once again, this latch point will make the moving contact to be away from the fixed contact to release the tension, right. So in both the cases, let that be in the case of over current or let that be in the case of over voltage, both in the cases the protection would be provided either with the help of bimetallic strip or with the help of trip coil. The manual operation can also be done. For the manual operation, the operating lever is being provided, right. So the circuit breaker can be operated manually with the help of operating lever, right. Once again, if the MCB is operated with the operating lever and is made in the off condition, right, in that case, once again, the lever, once this is being pulled down, once again, this would be once again connected to the latch point. So once again, it will be resulting in the displacement of the latch point, thereby making, because this latch point is being connected with the spring tension, right, with this moving contact. With this moving contact, it is being connected with a spring tension. So as soon as this operating lever is being made down, then this latch point will once again be, the spring tension is released. Because of that, this latch point is displaced. Because of that, this moving contact would be away from the fixed contact, thereby making it to be in the off condition, right. This is the working of MCB. The another protection device or another component of the switchgear, low tension switchgear, that is MCCB, that is molded case circuit breaker. So this is the practical molded case circuit breaker being shown. If at all I say the functioning, right, the functioning of the molded gauge circuit breaker, it is once again a type of electrical protection device that can be used for a wide range of voltages and frequencies, and it used to work for both 50 Hz and also for 60 Hz. The main distinction between the molded case circuit breaker and the miniature circuit breaker, which we have just seen earlier, are that the MCCBs, these molded case circuit breakers, they have higher current ratings, right, and they are having the ratings up to 2500 amperes. Their trip settings are also normally adjustable, which is not the function in case of MCB. The trip settings are not adjustable in that. The current setting was also, the current rating was also very much lesser, right. So the MCCBs are definitely, if they are working for higher currents, so their size is also going to be larger, right. The MCCB has three main functions, right. One is the protection against the overload, which is provided by the bimetallic strip. The functioning is almost the same, right. So the protection against overload is provided by the bimetallic strip, right. When it's get deformed, it will be once again the trip unit as well as the plunger which is attached to it, that will make the displacement and make the moving contact to be away from the fixed contact. The another one, protection against the electrical faults. It will provide the protection against the electrical faults or the overcurrents, right. And the last one, that is switching a circuit on and off. So this is the less common function of the circuit breakers, which are generally not being found, right, but they can be used for the purpose if there is not any adequate manual switch being provided, right. The wide range of the current rating available for this MCCB circuit breakers, they allowed them to be used in wide applications, right. They are having the wide range is varying from, if at all I say, it can be working up to minimum of 15 amperes to 2500 amperes, right. So it can be working for both lower power application as well as higher power application. The operating mechanism once again includes the overload protection I have just mentioned, which is being provided by the bimetallic strip. So the MCCB, it is having a bimetallic contact which expands and it expands and contracts in the response to the change in the temperature, right. So under the normal operating conditions, the contacts allow the electric current through the MCB. However, as soon as there is a variation in the current, there is the current used to exceed the normal working current. So the adjusted trip value, the contact will start to heat, right, and expand until the circuit is interrupted with the help of trip unit, right. On the other hand, the fault protection, the overcurrent protection is accomplished with the electromagnetic induction, and the response is very instant. So the fault current should be interrupted immediately, no matter if the fault duration is shorter or long. So whenever a fault occurs, the extremely high current induces a magnetic field in the trip coil, in the solenoid coil located inside the breaker. This magnetic induction trips the contact and the current is interrupted, right. As a complement to the magnetic protection mechanisms, MCCBs have internal arc dissipation measures to facilitate interruption. How that is being tackled, if at all I see here, right. Once this moving contact is being away from the fixed contact, right, because it is operating at very higher currents, very higher voltages, so there used to be an arc protection, right. So the arc protection used to be there in between the moving contact and between the fixed contact. Because of this arc runner, this is the arc quenching system what we used to have, right. So because of the arc runner, that arc used to move up, right, towards the arc runner, and these arc splitter used to, once again, the arc used to move up, and with the help of these arc splitters, the arc is being quenched, so that the protection against arc is also being provided. So there is no arc being remaining. So this is the internal arc dissipation measure which is facilitating the interruption in MCBs and also the MCCBs. The another important component of low tension switchgear, that is ELCB, that is earth leakage circuit breaker. Now what is an earth leakage circuit breaker? As the name is suggesting, right, it is a device that provides the protection against earth leakage. There are generally two types, right. One, the current operated earth leakage circuit breaker, and another one is the voltage operated current earth leakage circuit breaker. First, going with the current operated earth leakage circuit breaker. Now it is used when the product of the operating current in amperes and the earth loop impedance in ohms does not exceed 40, right. So such circuit breakers is used where consumer's earthing terminal is connected to a suitable earth electrode. These two are the important things in current operated ELCB. The circuit goes like this, right. Here the current operated earth leakage circuit breaker is applied to a three-phase 3-wire supply. A three-phase 3-wire supply. It is being supplied with a three-phase 3-wire supply. With that, in the normal condition, if at all you see, there is no earth leakage, then in that case, the algebraic sum of the currents in the 3 coils of the current transformer. For the protection, we are using current transformer, 3-phase current transformer. So if at all there is no leakage, then what will be happening? The leakage current in the currents in the algebraic sum of the 3 currents which are flowing in the 3 windings of the current transformer, that is going to be 0, right. If that is so, no currents flow through the trip coil, right. There will not be any current which will be flowing through the trip coil. So in that case, there is no circuit breaker operation. But in case of any earth leakage fault, if at all there is certain earth leakage fault, obviously the 3 currents, the algebraic sum is not going to be 0. I will be having certain current in the trip coil, right, which will be making the circuit breaker operational, right. It will be, the trip coil will be energized and the circuit breaker is tripped. This is current operated earth leakage. What is now the voltage operated earth leakage circuit breaker? Now it is suitable for the use when the earth loop impedance exceeds the value, which value? 40, right? Applicable, and this is, I mean, if that value is greater than what is being applicable to the fuses or the access current circuit breaker or to the current operated earth leakage circuit breaker, and for the earth leakage circuit breaker, that value we have seen it as 40. So, if the product exceeds the value of 40, we will be going with the voltage operated earth leakage circuit breaker. Now, how does this operate? So, when the voltage between the earth continuity conductor, right, this is the earth continuity conductor, when the voltage between this earth continuity conductor and the earth electrode that rises to a sufficient value, say for a predetermined value, the trip coil will carry the required current to trip the circuit breaker, right. With such a circuit breaker, the earthing lead between the trip coil and the earth electrode must be insulated, right. In addition, the earth electrode must be placed outside the the resistance area of any other parallel earth which may exist. So, these two are the earth leakage circuit breakers. The last kind of low tension switchgear component what we are going to discuss, that is air circuit breakers. Now, what is an air circuit breaker? It is a kind of circuit breaker which consists of fixed and the moving contacts which are enclosed in an arc-queued chamber having air as an arc quenching medium. Air is only the arc quenching medium, right. So, these circuit breakers are usually used for the low voltage applications, generally what we just talk about low tension up to 1000 volts. Its current rating is also varying from 500 amperes to 1000 amperes nearly. So, they applies a high resistance. How does they work? That these circuit breakers, they applies a high resistance interruption method for the arc extension, right. That can be given by various methods. We will be seeing that how to increase the resistance of the arc. So, the resistance of the arc is rapidly increased to a high value during the opening of the circuit breaker in the fault or in the normal operating condition, such that the source voltage becomes incapable to maintain this arc voltage, right. How to increase that? So, the arc resistance, if at all I say RA is the arc resistance, that can be increased by many methods, right. What can be those methods? First is either the cooling of arc, right. Another one can be by lengthening the arc, making the length of the arc to be larger, or by reducing the cross section of the arc, and the fourth one can be by splitting the arc, right, by using arc splitters. These are certain methods. So, if at all we see here, this is an air-queued chamber which has been created. Here the contacts are closed, the arc contacts are closed, these are the arc runners, right, and whereas here the contacts are open. So, if the contacts are open, the arc is being made to run up to the arc splitters, right. These are the arc splitters, these are made to run through the arc runners, these are the arc runners. With the help of the arc runners, the arc will be moving up towards the arc splitter, and with these arc splitters, which are nothing but the iron splitters being made, with these iron splitters, the arc would be quenched. What are the applications of this these air circuit breakers? These air circuit breakers are mainly used for low voltage and low or high current applications, right. They can be used, as we have seen, between the current range of 500 to 1000 amperes. The air circuit breakers are generally used commonly in indoor low to medium voltage electrical installations such as power control cubicles or motor control cubicles, right. Air circuit breakers are preferred for the applications where there is a high risk of fire hazards, as these air circuit breakers have a very short arcing time, right. These air circuit breakers are used for the motors and capacitor starting and protection applications, as they are most suitable for the frequent and high speed operations. Air blast circuit type circuit breakers, these are widely used in the railway electrifications. So, these are certain applications of air circuit breakers. These circuits are being taken according to these circuit breakers are being taken from the certain books. The references for these books can be from the T.K. Nag Sarkar and D.C. Kulshrestha. I have taken some of the material from the Google search engine also. Thank you all for listening so nicely. Thank you.